In this video, we will discuss the construction and operating principle of Buchholz relay. Here you can see the construction of Buchholz relay. The relay is installed in the pipe connecting the conservator to the main tank. You can see here, this relay is installed between the main tank and conservator. Depending on the level of fault, whether it is incipient fault or serious fault, Buchholz relay has two tripping elements. One is upper tripping elements and another is lower tripping elements. So this upper tripping element consists of a float. You can see here, this is a float, and mercury switch. The float is attached to a hinge. You can see this is the hinge. So this float is attached to a hinge in such a way that it can move down or up depending upon the oil level in this Buchholz relay container. Mercury switch is fixed on the float. The alignment of mercury switch depends upon the position of the float. This means depending on the sloping of this float, the mercury switch moves downward or upward. If this float is moving downward, then mercury switch moves like this. If this float is moved upward, then mercury switch move like this. Right? So this is the float. This is the float. So if this float is moving like this, the mercury switch position changes like this. If the float is moved upward, then the position of mercury switch also moves like this. On the other hand, the lower tripping element consists of a flap and a mercury switch. So this flap is fitted on a hinge just in front of the main tank, transformer main tank, and this setup of lower element is done in such a way that when oil enters in this Buchholz relay from the main tank with the high pressure, then the alignment of flap along with the mercury switch attached to it will be changed due to the high pressure of the oil incoming from the main tank. So, for operating this Buchholz relay, there are two tripping elements. One is upper tripping element and for one is lower tripping element. Upper tripping element is connected to the alarm circuit and lower tripping element is connected to the trip circuit. Now the operation of Buchholz relay. When incipient faults occur within the transformer, such as an insulation fault between the winding turns or breakdown of core of the transformer, then heat is generated due to the fault current. This heat causes the decomposition of some transformer oil in the main tank, and this decomposition of oil contains more than 70% of hydrogen gas. Since the weight of hydrogen gas is very light, it tries to move upward towards the conservator. So this decomposition of oil, which produces 70%, more than 70% of hydrogen gas, tries to move upwards towards the conservator. You can see here the gas, it tries to move upward. We can show the produced gas by red color in the container. Now this float can be moved downward and alarm circuit can be on by two ways. One is due to the huge pressure of accumulated gas and another is due to the fall of oil level. Due to the incipient fault, the rise of temperature is very slow and therefore gas can be accumulated on the top. The pressure of accumulated gas will be more and therefore float can be moved downward and alarm circuit can be on. On the other hand, fall of oil level can be due to the leakage of oil and also due to the evaporation of oil through decomposition as a result of incipient fault. And due to this production of gas, the oil will be reduced. That means the production of gas causes the fall of oil level in this Buchholz relay container also, since this main tank is connected to the conservator through this Buchholz relay. If the gas is produced and oil level is reduced, that means the oil level in this Buchholz relay container will also reduced. And this fall of oil level as well as the pressure of this gas cause this float downward. So this float will be moved downward due to the pressure as well as the fall of this oil level. And if this float is moving downward, this means the mercury switch will be tilted like this. And due to the tilting of mercury switch, the liquid metal inside the mercury switch connect the electrode and therefore the trip circuit is complete and an alarm circuit is energized. So due to this tripping of alarm circuit, the alarm will be sound and necessary action can be taken further. Now the gas which is produced due to the incipient fault can be collected by using this release pocket on the top of this relay. After that, by analysis the nature and properties of the collected gas, we can predict the type of fault in the transformer. Now what happened during a serious fault? So when severe fault occurs within the transformer such as short circuit between phases or toward huge amount of heat is produced due to the high fault current. Therefore, huge amount of gas is generated in the main tank. When huge amount of gas is generated, the movement of oil is also increased in the main tank. Now, due to the increased movement of oil, the oil in the main tank rushes towards the conservator with high pressure. Due to the rushes of oil towards the conservator, it strikes the flap. So you can see here the rushes of oil strikes the flap. So when it strikes the flap, it causes the mercury switch of the lower element to close. You can see before the position was like this, but when the rushes of oil strikes the flap, then the position of mercury switch becomes like this. This means the electrode will be connected inside the mercury switch. So this mercury switch is energized the trip circuit of circuit breaker and immediately isolate the faulty transformer from the rest of the electrical power system. So this is how the Buchholz relay works during serious fault